Today we're going to talk about variables and expressions. But before we talk about variables and expressions, there are a few keywords that I want to go over with you guys when it comes to the 4 different operations in math. And there are certain keywords that tell you which operation you're going to be using. So for addition, some keywords that we use for addition, so you know you're adding, is if you see the words increase, sum, plus, or more than. So if you see that in a phrase, you know that you're going to be adding. For subtraction, some keywords are difference, decrease, minus, take away, or less than. So if you see any of these words, you know that you will probably be subtracting in your expression. Multiplication, there's not too many for multiplication. There's times and there's product. Remember, the product is the answer to a multiplication problem. So that's why when you see the word product, you will multiply because it's the answer to a multiplication problem. For division, not too many. You can, if you see the word divide, obviously it's division. If you see find the quotient, that's the answer to a division problem. Or if you are splitting things evenly or you're grouping things, that would mean that you would have to divide. Okay. Now, what are variables? Okay, since we're going to be talking about variables today, what are variables? Variables are letters that we use in math, and they are used to represent numbers that we don't know. It's to represent the unknown. So in math, when we use variables, it's the letters that we use to represent a number that we are trying to figure out or a number that we're not sure about. Okay. Now, expressions, there are 2 types of expressions. An expression is a number sentence. Okay, so you've been dealing with number sentences since elementary school. Number sentence is numbers plus operations, right? But there's 2 different types of expressions. There's algebraic expressions, and those are the number sentences that have variables. So here are some examples of an algebraic expression. 3n, although it's a very short number sentence, it's still a number sentence because you have numbers, you have variables, and there is an operation here. When there is a variable next to a number, we multiply. So this means 3 times whatever number n might be. Okay. Another algebraic expression, a little longer, is 2x plus 5. This one's a little longer. There's multiplication involved and there's addition involved, and then you have a variable. So that's what makes this an algebraic expression. Now, a numerical expression is what you're used to seeing since elementary school. It's a number sentence with no variables. So 4 plus 8. It's a number sentence and there are no variables. This one's a lot longer and there are no variables. So it's longer. You have exponents, you have multiplication, subtraction, and addition. So it is a number sentence, but it has no variables in it. Okay. Now, let's go on to writing expressions. So let's turn phrases into expressions, into number sentences. So if I give you the phrase, the sum of the product of 3 and x and 5. Now, that sounds very confusing. There's a lot of ands, but zoom in on the keywords. You are trying to find the sum. What are you trying to find the sum of? Sum means adding, right? We are trying to find the sum of what? Of the product of 3 and x and 5. So we're trying to find the sum. We're going to add up the product of whatever 3 and x are and 5. Okay, so first we have to find the product. We multiply before we add. Find the product of 3 and x. The product of 3 and x means we're going to multiply 3 times x. And then we can find the sum of the product plus what? Plus 5. So first we find the product of 3 and x, and then you can add it to 5. So here you can see we are finding the sum of the product and 5. The product of 3 and x and 5. Okay. Here's another example. Increase the product of 4 and a number by 2. So when we see the word increase, we know we're going to be adding, and we see the word product, we're going to be multiplying. What are we adding and what are we multiplying though? So we are trying to increase what? What are we increasing? The product. So we're increasing the product by 2. What is the product? Well, it's the product of 4 and a number. So first we have to figure out what the product of 4 and a number is before we can increase it by 2. So then our number sentence would be 4 times n for a number, find the product, and then we can increase this product by 2. So increasing the product of 4 and a number by 2 would be 4n plus 2. So you kind of have to break it down. Now, we can also change expression to phrases. Okay? Each expression has more than one phrase. There aren't infinite phrases, but usually there's more than one phrase for each expression. So here's an example. 5n minus 3. Okay, 5n minus 3. Now you can write it the way you would say it. 5 times n minus 3, but I did some fancier phrases here. Here I did decrease the product of 5 and a number by 3. So first I find the product of 5 and a number, and then I decrease it by 3. Isn't that what that shows? The product of 5 and a number decreased by 3. Okay. Another way to say that would be 3 less than the product of 5 and a number. 3 less than the product of 5 and a number. So first find the product of 5 and a number, which is what we did there, and then 3 less than that would be minus 3. So as you can see, one expression has more than one phrase that goes with it. And there's more, but these are the 2 that I came up with. Okay. Now, when I give you an expression, okay, and I tell you to find the value of that expression, finding the value of that expression means to solve the expression. Okay. Now, you can't solve it unless I tell you what the variable is. So if I just gave you 12x minus 2, there's no way you can solve that because you don't know what x is. But here I tell you x equals 3. So when we're solving expressions like this, the first thing we need to do is plug in the 3 where the x is. 12x means 12 times x. You don't plug in the 3 and it becomes 123. That's not correct. 12x means 12 times x. Since x is 3, it would be 12 times 3 minus 2. So before you even start solving it, you should plug in the number first for the variable. Then you do order of operations, which order of operations, multiplication comes before subtraction. So I would do that first. I get 36, rewrite it, and then 36 minus 2 is 34. Okay, let's do another one. Here I have AB plus 3C, where A equals 5, B equals 2, and C equals 3. Again, when you see variables next to each other, that means multiplication. So this means A times B, which is 5 times 2, plug it in, plus 3 times 3. So first you plug it in, and I like to write my multiplication with just parentheses around it. I don't really like to use the dot, and I definitely don't like to use the x since we use x a lot in algebra. So then once I plug it in, then you do order of operations. First you do multiplication because multiplication comes before addition. So I'll do that first, that's 10. And then you do the other multiplication. 3 times 3 is 9. And then 10 plus 9 is 19. So your answer is 19 for this one. The last one I'm going to do with you is one that looks like this. It looks like a fraction, and it is. But fractions are also division problems. So this is also a division problem. There's multiplication involved. There's division. That bar means divide. Okay. Now, for this, I have a lot of kids rewrite it. Okay. And they like to rewrite it like this. They like to rewrite it horizontally. And they say, okay, that's x times 10 divided by 5 times 5. Now, when you rewrite it like this, you would do, remember, multiplication, division are equals. Whoever comes first gets to go first. So when you do it like this, you would do the 8 times the 10 first, get 80, and then it would be 80 divided by 5 times 5. All right? So it would be 80 divided by 5 times 5. And then the next step you would do is division, but that would be wrong. Because if you look at this, they want you to divide the numerator by the denominator. And your denominator is not 5. It is 5 times 5. So if you write it horizontally, you need to be sure to put parentheses around the numerator and around the denominator, because you have to figure out what the numerator is first. You have to figure out what the denominator is first before you can divide. So please, if you're going to write it horizontally, you do need to put the parentheses around it. Now, personally, I don't like to write it horizontally. If they give it to me in fraction form, I like to keep it in fraction form. So when I fill it in, I like to say, okay, that's 8 times 10 above there. And then that is 5 times 5. Sorry about the announcement. Okay, so then we've solved what the numerator is first. That's 80. And then the denominator is 25. We're just going to ignore that announcement. Okay. And then you've got 80 over 25. 80 divided by 25. Now, 25 doesn't go into 80 evenly. It's a fraction. Simplify it. Okay. 5 goes into both. You can divide it both by 5 to simplify this fraction. That gives me 16 over 5. And then change it back to a mixed number, which that equals 3 1/5. So your final answer is 3 1/5 for that answer right there.